All right, what we're going to do today is we're going to continue on working with circles. We started yesterday just talking about the fundamental parts of circles and what they're called, and went over some vocabulary. So we're just going to kind of pick up today and go on from there. So our central question is, how can I solve for the area and circumference of a circle? Most of you have done this before, but there are a couple of things that might be a little bit new that you're not used to. But anyway, it is a 7th grade standard, so we do have to cover area and circumference of a circle. So we're going to take care of that today. So if you'll copy this essential question down, please. And then, if you will, then copy down this topic that's going to be on the next page, which is labeled area and circumference of circles. And then if you'll add this to your notes. So what we're going to start with is two questions over here on the left side. First one is, how do I find the area of a circle, and how do I find the circumference of a circle? So first thing we're going to do is we're going to start off with finding the area. We all know area refers to the inside space and amount it takes up. The formula we're going to use is area equals pi r squared. So pi times radius squared. And we just follow order of operations, so we do radius squared, then multiply that by pi, which we all know is 3.14. Formula for circumference is pi times diameter, which means 3.14 times the diameter. Yesterday we talked about the diameter being twice the radius, or another way it was netted is the radius is 1/2 of the diameter. So what I want you to do is, if you'll draw this pizza right here, you don't have to actually draw the pizza, you can just draw a circle that goes with it. Give me just a second, this board's messing up again. Alright, so if you'll draw a circle, and if you'll label the distance halfway across that circle, or pizza in this case, as being 5 centimeters. So we have a pizza here represented that has a radius of 5 centimeters. So if you will, add this to your notes. And let me highlight this part. So our pizza has a radius of 5 centimeters. What we want to do is we want to find the area and the circumference of this circle. So our area formula is pi r squared. And our circumference is pi times diameter. So what I'm going to do first is I'm going to just list my radius, I'm going to list my diameter. I just ask students to do that so they get that down pat. We know 5 centimeters across is our radius. Our radius is 1/2 the diameter, or another way of looking at it is the diameter is twice the radius. So we talked about this yesterday. So our radius is 5, so we do 5 times 2, which gives us 10 centimeters. So I'm going to just substitute each thing into the appropriate formula. So I'm going to work the area one right here so I have a little bit more room. So our formula is area equals pi r squared. I'm going to just substitute everything in. Pi is 3.14. So I'm going to just put a little note here, 3.14. If you need to, copy that down. Our radius is 5, so I'm going to say 5 squared. Then I'm going to just work through the problem using the order of operations. We have to do the exponents first, so I'm going to say 5 squared, which we all know is 25. Then we're just going to multiply 25 times 3.14, and when you multiply that, you get 78.5. So in this case, it would be 78.5 centimeters squared. So our area for this circle, or this pizza, is 78.5 or 78.5 centimeters squared. All right, so you'll get that down in your notes. An example of working this problem. And then if we can now work this one, the circumference. So let's now find the circumference. We know pi is 3.14. We know our diameter, because we figured out over here, our diameter is 10. So we're going to multiply 3.14 times 10, and you get 31.4. So our diameter is 31.4 centimeters, which refers to the distance around that circle or that pizza. So that is our circumference and area. All right, so now we'll go to the next example. Our next example is going to be where it says to describe a circle with a circumference of 3 pi meters or 4 pi meters. We're actually going to skip this part because this is going to come up in just a little bit when we refer to something else. So just ignore this for right now. All right, let's go to this one. what is the circumference of a circle with a diameter of 4 inches? One thing you might want to do is you might want to actually draw a circle. So we could draw a circle here. All right, it says it has a diameter of 4 inches, so we know the distance across would be 4 inches. And we want to find the circumference. So our circumference formula is pi times diameter. We know 3.14 is the value of pi, and our diameter is 4, so we just multiply 3.14 times 4, just very straightforward, simple problem of 12.56 inches. And again, that is circumference. If we wanted to, we could find the area. Oops, didn't mean to actually write it. Area is pi r squared. We know our diameter is 4, so our radius in this case would have to be 2. So we can say 3.14 times 2 squared. 2 squared is 2 times 2, which gives us 4. So we would have 3.14 times 4 gives you 12.56. In this case, it has an area of 12.56 inches squared, and the circumference is 12.56. So in this case, the circumference and the area is the same exact value. So I'm going to just highlight these things for you. All right, just gives you another example. The more examples you have, the more practice you do, usually the better off you'll be. All right, if you'll do this one, it says, what is the length of the tire track made by one rotation of a 20-inch wheel? So use 3.14, round to the nearest 10. So if I was drawing this out, which I want you to draw out, I would just draw a circle. And then what we can do is we can say the distance across is 20 inches, so you don't have to draw the unicycle. So it says, what is the length of the tire track made by one rotation of a 20-inch wheel? Now, if you think about it, the tire track represents how far that tire is going to travel in one rotation. So imagine taking a circle. Let me just have a circle right here. Imagine having a circle and us making a cut right here. If we made a cut right there on that circle or that tire and we stretched it out, and we stretched it out flat. So can you imagine this round circle right here being cut right here at this line and then just being stretched out? I apologize for that. The board's acting up. So imagine the circle being cut and just stretched out. So we have a 20-inch circle. So that means this tire, when stretched out, would be 20 inches. So that would be that representation of our tire track. Now, it would be that it's just, I'm sorry, it shouldn't say 20 inches there. Now, just because the diameter is 20 inches, that doesn't mean that tire track is 20 inches. Now, we know the distance around a circle is the circumference. So would that not be also the length of our tire track? So what we have to do is we would have to find the circumference, so pi times diameter. We know our diameter, in this case, is 20. So all I'm going to do is put 3.14 times 20, and we just multiply those two values together. So 3.14 times 20, and you get 62.8 inches squared. Oh, I'm sorry, it's not square because it's circumference. So the length of that tire track from one end of it to the other would be 62.8 inches. So that's how you would find the length of a tire track or one rotation of a tire, which would be just the circumference. So when you're asked to find a rotation, you're going to find the circumference. Now, what if it said, what would 2 rotations be? 3 rotations, 4 rotations? All you do is take this number and multiply it by the number of rotations. So if I want to know how far 10 rotations would be, I would just multiply 62.8 times 10. All right, let's go on to the next question. But before we do that, let me go ahead and highlight some things here because you will see some problems like this again. So we have our formula for pi, circumference, pi times diameter. Rotation of a wheel that's 20 inches, has a 20-inch diameter, would be 62.8. So that distance would be 62.8. So I'm going to have you copy down several things here. And if you draw this one right here, no need to draw another one. All right. So next question says, to the nearest tenth of a meter, what is the circumference of a circle with a radius of 3.5 4. So we're going to find the circumference of a circle. So we know it's pi times diameter. In fact, I want to do circumference and area. So we're going to find the circumference, and we're going to find the area. So we'll copy this down, and we know that it has a radius of 3.4. So you might want to draw a circle. So we're going to have a little circle here, and we're going to say that that has a radius halfway across of 3.4 meters. All right, so let's just substitute the values in that we have. We know our radius is 3.4. And if we have a radius of 3.4, we just double it. So if we double that, we would have a diameter of 6.8. So our diameter is 6.8. So we just multiply 3.14 times 6.8, and that gives you an answer of 21.352 meters. And it says here, round to the nearest tenth. So this 3 is in the tenths place, which means I'm going to look at the 5 right beside it, the number digit right beside it to the right. That number to the right is 5 or more, so that causes that 3 to go up. So that answer round to the nearest tenth would be 21.4 meters. All right, let's now find the area. We know area is pi r squared, so I'll substitute 3.14. Our radius is 3.4, and that has to be squared. So the way we square 3.4 is do 3.4 times 3.4. So 3.4 times 3.4 gives you 11.56. And then we just multiply that times 3.14, and we get 36.2984, rounded to the nearest tenth. So we're going to look at that 9, which means it's 5 or more, so that rounds to 36.3 meters squared. And so there we have the circumference and the radius of these two. So what I'd like for you to do right now is, if you will, actually let's stop right here. I'm going to have a second video for this.